talk a little bit about them. So as this function approaches -2, it have a limit. As this function approaches -2, this function have a limit. Okay. The answer is no. So, okay, I was on -2, and that should be a +3. I don't know why it's a -2 there. So as it approaches, we'll call it -2 if I'm going by their increments. This would have no limit because there's two different ones, right? They're not going to be approaching the same for the function to have the limit. So if you're approaching -2, well, this is starting to say this should say 2, not 3. Oh, sorry, it should say 3. I wasn't reading my statement right. As x approaches 2 from the left side, the value of f of x, so the value of the function approaches 3. If you're approaching from the right side, it's approaching 1. So we'd say that this does not have a limit, or the limits defined, because they have to actually be approaching the same place, and they're not. We've talked about that. So the notation for a left-hand limit is simply just saying, and we looked at this before, as x approaches a value from the left-hand side of the function. So we indicate that it's the left-hand side by putting a negative. It doesn't mean the values are negative, it just means that you're coming from the negative direction. And then the right-hand limit, similarly, is going to be x is approaching some value, and it's going to have a positive. Again, it doesn't mean that the values are positive, it just means that you're approaching from the right side. Those are usually indicated as a positive direction. That's it, easy peasy. No more than do this. All right, so looking at this function, we have asymptotes, we have poles in the graph, we have all kinds of magical things. So the limit approaches -1 on this graph. What's happening? Is there a limit? Okay. There's -1. -1 is actually an asymptote. Not just a freak us out because we know we can have limits. We can have limits when there is no point, right? When there's no actual dot on that graph, we can still have a limit. The reason why we have no limit here, you're not wrong. That's supposed to be an I, we'll just go with it. If you're approaching from the left-hand side, where's your graph approaching? Up, positive infinity, or up? Either like positive infinity better. If you're approaching from the positive side or the right-hand side, your graph is approaching negative infinity. Two different places. Two different places, so we say that there's no limit. Okay? If we say g of x approaching 0, so it would be 1. Because the right-hand side is approaching 1 and the left-hand side is approaching 1. Nice and easy when there's a dot there. And if we say g of x, the function going to positive 1, no limit, because there's 2, right? You got 2 points there. You have 1 if we're approaching from the right-hand side, it's approaching 2, and if we're approaching from the left-hand side, it's still at 1. And then g of x going to 2. So as the function approaches from the left-hand side, it's going to a 2, and from the right-hand side, it's also going to 2. Pretty straightforward stuff, easy peasy. Way easier than L3. So far, I haven't had to do much mathy stuff. You've just been looking at it. Big table of filling next time. Where's my graph go? You guys have a graph? Really? Well, why didn't I put it on the same page? Okay, this screwed us up last time, right? So I thought I should try it again. Oh, that's the wrong graph. do anything with it. Just want you to go away with the wrong graph. Okay. Let me scroll down and get the right graph. Here. All right. That's what I want to do. I want to send this to clipboard. Perfect. Now I'm going to go here. I don't know why I just didn't do this for you guys. Awesome. Okay. All right. Woo! That took way too long. I will eventually figure this out. It's not a ton of number for you. All right, that's way easier for me. I don't know about you guys. Okay, so now we're doing left-hand side, right-hand side. We did the general ones on the other page. So approaching G of X is the inner one, we talked about this. Where is it going from the left-hand side? So if I'm coming in to -1, where am I going? Not up, we're going to positive infinity. If I approach G of X at -1 from the right-hand side, where am I going? Negative infinity. It's very odd to see a negative with a 0, but it's not a negative in front of it, it's a superscript, almost an exponent. So G of X at 0, approaching from the left-hand side, is going to 1. And if I approach it from the right-hand side, 1. Okay, I'm going to tell you, if these aren't the same numbers, then you screwed something up on your other circle you told me it was. Where are we going next? You're going to approaching +1 from the left-hand side. From the left-hand side, where am I approaching? You guys can say it. Left-hand side, we're approaching 1. Even though the open circle is there, remember we're a limit. We don't care if it actually exists. We just want to know where we're going. So we're also going to 1. G of X from the right-hand side, where are we going? 2. So this is why we had no limit. And here we had no limit of the function on the other table. Does that make sense? Because they're approaching 2 different places. And then this one at +2 from the left-hand side, we're at 2. And from the right-hand side, we're still at 2. So this had a limit because they're both the same. This had a limit because they're both the same. And then no limits here. Woo! All right. We're going to make a statement about that. I'm sure you get it. You like that? My little, I always put this, nobody knows what it means, but it means therefore. We'll triangle with dots. You guys are okay if I write right-hand side like that? Talk about that. If they don't equal the same thing, the limit for the function doesn't exist. Good times. You can express it as the right-hand limit versus the left-hand limit, just like we did here. right-hand limit, left-hand limit, looking at that graph. And then you can state their difference so there's no limit to the function. Easy peasy. So piecewise functions. Remember those from grade 11? Good times. All that is we're just looking. I didn't waste your time graphing it, but if you really did want to graph it, we're going to look at x being less than positive 2. So I would only graph any values of less 2 or less than. So if I put 2 in here, that would be 4, 12. 12 minus 4 is 8. So at positive 2, we're at 8. And then if I put 1 in here, we'd be at negative 1. And if I put 0 in here, we'd be at a negative 4. So essentially, if I put in a negative 1 here, if I put in a negative 1 here, we'd still be at a negative 1. So you would be this part of your graph. This would be a closed circle because that's where it starts, but it doesn't go beyond that, assuming that that's 2. And now here, x plus 6, I'd be picking, and notice it's got the inequality sign without the equal. So if I put 2 in there, we would be at 8, which was that my top part as well. So this would be also an open circle at that point for that section of the graph. If I put 3 in there, I would be at 9. If I put 4 in there, I'd be at 10. So I got a line like that. Oops. What did I do? What did I do? I went too far. I got too excited. Graphing can do that to a person. So your arrow will only extend this way. I don't know if I would take the time to actually graph that. Does this, okay, so I took the time to graph it. Does this have a limit? Does this function have a limit? What is it? No, you're approaching to H. It worked out because I showed you the graph. But if you wanted to do that, all you have to do is say, okay, approaching from the left-hand side, if I substitute 2 in here, so actually let's do more room. The limit as x is approaching 2 from the left-hand side, we're just going to check where this graph goes out, which we already did that when I was doing the math. So I'd have 3 times 2 squared minus 4 gives me 8, right? I did that with my pretty picture. I'd do that in my head. So then I would say the limit as x is approaching 2 from the right-hand side. I check what 2 does in this one. So 2 plus 6, that also gives me 8. Because they're both at 8, which we saw from the diagram, my limit of the function, I'm going to write that down here, is equal to 8. So there is actually a limit for this piecewise function. It doesn't always happen this way. But they're both starting at that positive. That's tough. That's exciting. I don't think I waste my time graphing it, but if the graph helps you, I mean, a rough sketch on the side will do the same thing. Not all piecewise functions are given in piecewise form. Absolute values are piecewise functions. Okay? Because you have the part, that's what you wrote piecewise functions for, the part that got flipped up versus the part that was part of the original. You guys ready for this? Super excited? I can tell. Okay, so here's the thing. So case 1, what's the deal with case 1? What do we do with case 1? Go back to grade 11 when you're solving absolute value equation. You just do the original without the x. So case 1 would be my right-hand side because that means everything's positive, right? If I haven't done anything to this, it is what it is. So this would be Okay, this is a great example. What would my limit be approaching? I didn't even give you a value here. What would it'd be 4, right? It's always a non-permissible value. So my non-permissible value of this absolute equation is positive 4. So we're looking for where the limit is approaching. Make sense? There's one. Okay. Oh, wait. All right, so let's solve this. Okay. This is pretty easy peasy. 2 take out a 2. We get x minus 4. X minus 4. Those cancel each other. I get a 2. Okay, so piece 2, what do we do? Take the absolute, but when we're solving an absolute equation, what does that mean mathematically? What do? Go back to grade 11. Yeah. So, what are you going to tell me to do with that? Come on, grade 11. You multiply everything in the absolute value by -1. So not just the x values, not just the y values. So this would be my left-hand side because I'm coming from a negative direction. So this now would be negative 2x plus 8 over x minus 4. So if I take a negative 2 out of here, do I have a limit for this function? No. So this is pretty exciting. So the new definition of the function, so we know that when you are greater than 4, when you're less than 4, you're a -2. When you're greater than 4, you're +2. How come neither of those have an equal sign attached to them? What's happening at 4? An asymptote. Right?
Yeah.
You have no idea what. Okay, so this is why I don't have the equal sign on either of these, is because we have an asymptote. Right, so neither of those could equal that. So we found out when we're approaching from the left-hand side, it's going to be equal to a -2. When we're approaching from the right-hand side, it's going to be a +2, and the limit does not exist because they're two different things. So if this simplified to an actual expression, like if it's simplified to 2x or something like that, that would be written here. It just so happens that this simplifies to an actual constant. So it becomes a constant function. But you got to do case 1, case 2. So when you see an absolute question, it's really a piecewise, the left-hand side and right-hand side. So you got to solve it out or simplify it in the case 1, case 2 from grade 11. Undefined limits. Let's say undefined limits. Why are these different than our indeterminate? So if I substitute 2 in here, if I do a direct substitution, I get 7 over 0. What's an indeterminate? 0 over 0. So this is an undefined limit because I have a value in the numerator. Will I ever ask you the difference between those? So undefined limits just have a 0 on bottom. All right, so this is the deal. You're going to go back to kind of your table of values. I know you're all pumped to do this math, but I got it happening in my calculator already. So I substituted in from the left-hand side. So on left-hand side, I'm getting closer and closer and closer to 2 from less than 2, right? I'm getting as close as I can. So this is negative 66. This one's negative 696. This one is a negative 6,000. Negative 6,996. This one is a negative 69,996. Do you notice the pattern? I know. It's just my little bit of excitement in the day. Something happens. So what would you say left-hand limit as it approaches 2? Where am I heading to? Negative infinity, because the next number will be just one place value bigger than that. So if we're approaching from the left-hand side, we're headed towards negative infinity. Like I said, if all else fails, if you don't remember any of your theorems, you don't remember anything, you don't know how to use it, you have a mental breakdown on a test or a quiz, your table of values will never fail you. So now I'm going to the right-hand side. So I'm going from a bigger than 2 on my way towards 2. So this one was 74. This was 704. This one was 7,004. 70,000. 700,004. So where am I headed towards? Positive infinity. So what's my limit of the function? Not hard. Left-hand, right-hand limits are not hard. Okay. So if I substituted in a 2 here, this would result in 1 over 0. And I can't have that. So now, I'm not going to make you do a table of values. I'm going to make you think. Yeah, that could be hard. It's a Friday, and I'm asking you to think. So if we're approaching the limit to 2 from the left-hand side, what kind of number am I throwing in there? Like a 1.999, right? You guys agree with me? So if I put in a 1.99 something, what would be left here? 0.00. It'd be a really, really small decimal, right? A really, really, really small decimal. And I'd be squaring it. So I'm just going to write this as it's a positive small decimal. That's exciting. Didn't do any math. I just make it a statement. So if I take 1 and divide it by a positive, really, 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 really small number, what's the result of that? A positive big, big number. That's exciting. So what, instead of calling it a positive big, big number, what would it's kind of like the graph goes up. Where am I headed towards? Positive infinity. I kind of like big, big numbers, but they already named it as infinity, so we can only do it. So now if I'm going limit from the right-hand side, so this is a 2 plus 0, 0, 0, 0, 0, 1, right? Like we're adding like a really, really small number. This is that h out we did in limit 3. What are we adding to it? That's really, 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 really small. So this would be 2.00001, right? So when I subtract 2 from it, what do I get? And then I'm going to square it, so it's going to be another positive small number. Sorry, I'm just behind here. here. So this is going to be 1 over a positive small number. That's squared. This one would have given us a negative, but once we squared it, it gave us the positive. And same thing here. So we have a positive small number. So we're headed to a positive big number again, which is called infinity. So what's the limit of this function? Because we have one. Now we're infinity. So this is equal to infinity. So that is your left-hand side, right-hand side limits. Those are nice and easy. Those are not going to be on your quiz on Tuesday. Okay, and then we're going to do one lesson 2, and then I'm going to give you a problem set, and you put your first